For this standard, students should first be able to explain why fractions are equivalent using visual fraction models. So they should be able to explain how the number and the size of the parts differ even though the fractions are the same size. So here, if I have an area model of 1/2 and an area model of 3/6, students should recognize that the models represent different fraction names, but that they show the same quantity, so the fractions are equal. So they should then be able to expand their reasoning by saying that there are more parts in the second model, but that the parts are smaller. So each half has been split into thirds. So here I have 3 pieces, but my pieces are smaller than the 1 piece here. Then that reasoning helps them begin to generate a rule for writing equivalent fractions, which is also a part of the standard. They can show and represent their thinking mathematically by showing that each part of the fraction was split into smaller pieces, which made more pieces. So in this one, the shaded part was divided into 3 smaller pieces. So it represents 1 times 3 of those. And the entire model, both halves, were divided into 3 smaller pieces. So it represents 2 times 3 of those. So by reasoning about the connections between the area models, then we can see that 1/2 is the same as 3/6 mathematically here too. They're able to generate a rule for that to show that the numerator was multiplied by 3 and the denominator was multiplied by 3. The standard explicitly has students connect the visual model and explanation to the rule. So the traditional algorithm shouldn't be taught without making that conceptual connection every time to the models. The traditional algorithm will be taught in the 5th grade.